Hey guys, welcome back to my channel, Logically Literate. In today's video, we're going to go over DeQuaN and how far he's come after about 13,400 games played, and if he's gotten any better or any worse in that time. So stick around and I hope you enjoy the video. So currently what you're seeing is game 13,428 of this current model. I'm only training up to 10,000 games right now, but this current iteration played to 10,000, and then I loaded the model up, set epsilon to 1, and then continued another 10,000 games. So it was essentially the same thing as if I were to play 20,000 games the first time. Around, I want to say 7,500 games, DeQuaN did what seemed to be a smart thing. He would essentially set his turret away from the target, shoot a probe, adjust it, shoot again, adjust it, shoot again, adjust it, shoot again, adjust it, shoot again, until it essentially got closer to the target. But then it would adjust past the target. So it wasn't really doing what a human would do, where it would essentially shoot a probe shot and then walk it in towards the target. What it was really doing was just shooting away from the target and then scanning across and eventually shooting past the target. And as you can see here, it does this thing where it just kind of, sometimes it'll just stay at a certain angle and it'll just shoot straight. Now you can see it has 0 power, set itself to 0 power at the beginning before it shot once, and now it's shooting itself. So as you can see there, he just set his power to 0 and he's just shooting himself. I've not seen this happen until right around 3,431 games, which is where I'm at now. Or I should say 13,431. Something I'm not quite understanding is the methods that DeQuaN takes to play this game are fairly random. One game you'll see he does this where he turns 180 degrees away and just starts shooting backwards. Another game you'll see he keeps his initial angle about and then reduces his power to 0. And like I said, back in like 7,500 games played, he would angle all the way away and then slowly walk towards the target, but then past the target. So it kind of seems like it's learning different methodologies, ways to play the game based on the initialization of the game. So I don't think it's quite necessarily learned how to correlate what it's doing to the reward it's getting, or what it should be doing to the reward it's getting. And that could be a problem with my reward function, which is more than likely true. I don't think I'm vicious enough on bad actions, and I don't think I'm rewarding enough on good actions. I also don't think that the way I'm handling now, where any shot is worth up to 5 points and down depending on the distance to the target that you shoot, I'm not sure that's really a good approach. Part of me wants to just say you get 0 points when you make any move other than when you hit the target. From what I've heard, doing something that's kind of more like discrete like that, where it only gets reward when it does the thing you want it to do versus giving it a gradient, is that you will end up training a lot longer than you would otherwise. One issue I'm currently having is, even when the game is headless, it takes about anywhere between 15 to 30 seconds to play a single game. When I trained 10,000 games last week, it took about 4 days to complete 10,000 games. So one issue I have is that I don't have the bandwidth to play multiple games and try different reward functions, mostly because the reward function is so deeply integrated into the code. It's not really modular. So I kind of need to parameterize the reward function in such a way that I can essentially give it a config file that tells it what its reward function is, and then then I'll be able to essentially randomly generate these config files with some amount of rules, and then I can spin up multiples of these games at a time. Because if you look at my CPU, I'm only at like 15%, and right now I'm running a remote desktop too. So I'm really only using a part of it. And if we look at the process that's actually running this Python process, it's only like a 6.8% with like 165 megabits of memory. So really I should be playing like 10, 15, 20 of these at a time on this CPU. It definitely can handle it. So one of the things that I've done was graph some metrics at the end of every game. So I'll go ahead and go over these graphs and how I came up with them and why I'm using them. The third one, epsilon, isn't really useful. I just wanted to see how the game plays compared to the randomness / the use of the model throughout. So the first graph, you can see one thing to point out: the x scale is the number of games played, so the game number, and the y scale is different for each graph, but the x scale is the same for every single graph. That way we can look vertically at every single graph and see how different things correlate. So the first graph we see wins for player 1 versus games, and in the second graph we see wins for player 2 versus games. You'll notice player 1 has a very jagged graph going upwards over time, and you'll notice player 2 has a very constant graph. It's also kind of, it's 10,000 games, so it's not a very zoomed in graph, but one thing I do see is that right around 4,000 there's a huge jump in wins as compared to the rest of the slope, and the same can be said right around 5,700 games. These were the places where I kind of noticed DeQuaN was starting to do something a little bit more logical, where it would walk in its shots. And then again at the end, right where it's about at, let's say 9,000, it takes another big jump. And so really what that first graph does for us is where we see those jumps, that kind of tells us that around that 50 game window, we saw an increase in wins, which means that the model was a lot better. Another thing you'll notice is if we look at the bottommost graph, this shows the health of player 2 at the end of every game. So you'll notice that when the player 1 wins have a jump, the health of player 2 has a much denser set of points in closer to 0. So around 4,000 you can see right around here it's very dense with low health, and that's also where we notice this jump in wins. Around 8,000 we see a low amount, and then around 10,000 we see a pretty low amount. And this right here I actually really like because although they're not all at the bottom, we have a really nice density in the center, which tells us that DeQuaN, if he had a little bit more time, probably would have won these games. Whereas when you see these kind of one-off ones like this, that basically means he got lucky. What I was seeing was about 0.5 to 1% of the time. It was such that if DeQuaN just sat there and shot randomly, and by randomly I mean consistently in the same location that it's initialized to, he would get a kill. So really when we see this nice density here, that's really good to see. I'd like to see this kind of plateau out to where his wins go down and maybe hit a limit over time, or even reduce. Although I don't think they would ever reduce because it's a sum, it's not a running total. So yeah, we'd want to see that kind of plateau out. Whereas this one we'd like to see an exponential increase in a way, and really just this scale here is really what we want to see increase. We don't want to see it be 100, we want to see it be 10,000 like this one. And then another kind of thing to look at is the more points and the more density we see at the top means the worse DeQuaN was doing. So over here we have a lot of density at the top, which means obviously he didn't really kill player 2 all that often. But then again, like I said over here, less density at the top, more density at the bottom. That's a good thing, meaning towards the end of the game, the player's health was a lot lower. And so I can kind of use this graph, and I can use this graph to show me how he's doing over time and how he's progressing. These graphs are generated at the end of a training session, so I'll only generate these every 10,000 games. However, if I wanted to have a more clean look into each section of games, maybe 2,000, I could train for 2,000, have it generate, and then load that 2,000 game model, and then run again for another 2,000, and just continue to iterate like that. That would give my graphs a little bit more readability. So that's pretty much it for an update. I'm going to let DeQuaN train for another 10,000 games and see how he does. Once I have the 20,000th game played, I'll probably take the graphs and data that's generated and do another video like this, just kind of describing how the last 10,000 games went. But until then, thanks for watching. If you enjoyed this video or found any of this helpful, go ahead and like and leave a comment below. If you have any questions, make sure to comment below, and I'll get to that as soon as I can. Make sure you hit that subscribe button, and catch you in the next one. Thanks.